Hello and welcome to Advanced Skimmer Basin Design using SedCAD. This is going to be a deep dive, just short video, just focused on designing sediment basins using SedCAD. It's part of a series of videos that we're doing. So previously we did a video to understand just the basic skimmer design based on volume for sediment basins. This one, as we said, is Advanced Sediment Basin Design using SedCAD, which is a sediment trapping software. Uh, future training series coming out, we're going to talk about skimmers for permanent use, go through a couple of case studies, advanced skimmer modeling in hydroflow, volume-based versus filtration-based water quality, specifically in stormwater basins. And then we'll talk about water quality modeling with a focus on volume-based designs versus filtration-based design. And that'll be an instructional video guide as well. For this, we're going to look at a sample site that was a project done in Greenville County, South Carolina. So for those not familiar with SedCAD, it is a software that was developed for use primarily in mining. It does sedimentology, and depending on the MS4 you're at, some of those will accept SedCAD design, sediment basin over a more empirical volume-based design. This is going to be a run through. This is not going to get into every detail of SedCAD. It's going to assume you have some basis of SedCAD use, but it's going to specifically talk about how to model skimmers in SedCAD. But we'll go through and do some of the steps as well. So again, we've got an existing site. It's proposed to be a new warehouse. It's got a sediment basin down here that is going to also end up being the permanent detention pond as well. So one of the first things you do is you look at your map for sedimentology. And so in this case, we have 10.1 acres total going to the sediment basin. 3.3 acres of that will be disturbed. So then we've got a proposed sediment basin here. So you've got your outlet structure. And during construction, we've got a skimmer put in here to meet the surface withdrawal requirements, emergency spillway, and a rock outlet here. This pipe here is catching some bypass water coming around the basin. So first thing you want to do is confirm your design type. So in South Carolina, specifically Greenville, it is a type 2 storm, and the design storm is a 10-year, 24-hour storm. And for this area, it's about 5.5 inches of rainfall for that storm event. You're going to check sedimentology here, and then you're going to need to put in your particle size distribution for the sedimentology calculations. We use a soil survey, just a standard NRCS soil survey to determine the soils for the site. In this case, it was a Cecil soil, which is a predominant soil in the Greenville, South Carolina area. The particle size distribution, you fill in that table with the particle size information. And again, you got your storm information here. Then you're going to input your network and routing information and your subwatershed information. So in this case, we've got this subwatershed 1, that's our disturbed area, 3.1 acres, subwatershed 2, 7.37 acres, that's undisturbed. Got your time of concentration here. You can do your stormwater routing. In this case, we didn't fill that in because it's a short distance between the two, basically coming out the same point. Curve number, we use an 86 for bare earth conditions during construction. Hydrograph response, typically as medium here. It depends on your area. For our area not included in the site, the 7.3 acres, had a curve number of 69. That was sort of an undeveloped area, partially developed area upstream. You're going to put in for your sedimentology. You're going to have a K factor that's based on your soil erodibility. Just click the help in SedCAD to come up with what that K factor should be for your soil conditions. Your length and slope, that's going to give you basically the length and slope of flowing to your basin there, flowing across your site. The C factor, that's going to be 1 for bare earth. And we use a 0.05 for the basically native undisturbed area. P factor, that is typically a worst case scenario of 1. Again, you can check the SedCAD help on that. Particle size distribution, we've got that in there as Cecil. And again, you've got, check your disturbed for your on-site area that's being disturbed and leave it unchecked for your off-site area or area that's not disturbed, but also going through your model. So then you want to model the skimmer sediment basin itself. And so you're going to create a pond. When you do this, typically you're going to set your dead space if you've got baffles in there. Typically we use 20. 0 is not very conservative, so you want to go with a 20% as your dead space. Then you're going to go to your structure design. You're going to probably already have your basin generally designed, kind of a trial and error, but you'll have your contour elevation and area at each elevation that you've come up with for your sediment basin. Here's one of the important things is whenever you're putting in your elevation area into SedCAD, you're going to manually enter that elevation and then the area in acres in SedCAD. So you're going to have to convert from square feet to acres. You want to set this elevation area table stage increment to 0.10. What that does is that's going to give you data points where you can enter the skimmer flow later, and you're going to view your input values. So just manually enter your elevation and your area into your table to plug this in. Put some of these other elevations in here for specific points on the model. So then what you're going to do is you're going to set up your enhanced perforated riser as your primary spillway option. And that's going to put in this case, we had a 48-inch diameter riser. It was 7 feet tall, had a barrel of an 18-inch barrel going out for 48 feet at a 2% slope. The Manning's end was 0.013. That's for a concrete pipe. And we set our spillway elevation. That's the top of the riser. So at 849, that sets the bottom of the riser at 842. And you can also, when you put your orifices in, you can select the number of holes per elevation. Set that in as 0.1 typically, although sometimes you'll have more than one. Then you've got over here your elevation information and your spillway discharge. Again, this riser doesn't have any orifices in it at this point, so it's not going to have any discharge until you put in to get to the top of the riser. So typically you don't include any additional orifices in a riser for a sediment basin. There may be some times where you've got to do volume control during construction, and you may let the skimmer control a certain part of that and then you have some other orifices. But typically what we see is we have a riser, and then we use this user input discharge. And so when you do your user input discharge, you're going to go over here and you're going to manually enter in the discharge at each point. Now, you're not going to have to interpolate between each point at every 0.1 elevation. So at the bottom, 842, you've got 0. At 0.1, you're going to have a value. That value is going to come off the skimmer detail. There's a chart on all the details with the flow value, and it's at 0.1, 0.3, and then every half a foot. This will blow up the table. So it goes from 0.1 to 4 feet deep. Now, if you go over 4 feet deep, you can either maintain that flow rate at the 4-foot depth, or you can extrapolate it out. So in this case, we plug in our 0.1, our 0.3, then 0.5, and then at that point, we put in every half a foot value based off that table up to our depth. And then we extrapolated this one over 4 feet. And then SedCAD will interpolate between those. You don't have to go figure out every 1/10 of a foot elevation flow rate and interpolate between that. SedCAD will do that for you. Again, I said if basin's depth is greater than 4 feet, you can use the max flow rate at the 4-foot depth or extrapolate it. In this case, you'll see we just kept that the same once we got over 4 feet deep, and we just used that flow rate at 4 feet. If you want to get more accurate with that, you can go to our design tool. We discussed the design tool in the previous video, but you can go back to it. You can set your pond depth up here at whatever your depth is to your riser, and then set your length and width ratio so it's pretty close to what that is. But really, that's not going to be that important. It's really just the pond depth is important. And then our tool has incremental values that it will calculate. So you can see it spreads these increments now from 0 to 72 inches for our 6 feet. And then it'll give the skimmer flow rate in CFS for each one of our skimmers. So you'll see here, it's 0.38, 0.38. Then when you get up here over 50 inches, it goes to 0.39, and up about 58 inches, it's going to 0.4, and at 68 inches, 0.41. So you see a 0.03 CFS increase between basically our 4-foot depth and 6-foot depth. Obviously, they'll have a little bit of impact, but not a lot of impact. But if you really want to accurately model that, you can use our tool here and put those flow rates in. Once you have that, you just run the model. And what you're looking for, at least in South Carolina, is that you want to hit an 80% trapping efficiency here. And so you're going to have all your pond information, your sediment storage, your dead space, your riser information. It's all up in here. And then the elevation capacity discharge table. You'll see the discharge here should match what you pull directly off your skimmer. And again, one thing interesting to note here, our dewatering time was 1.52 days, but we hit 80% trapping. That's kind of the magic number you're trying to hit. You also typically you're shooting for a 2 to 5 day drain time in South Carolina. However, what we have seen is reviewers typically, if you hit the 80%, that's their main concern, not necessarily the dewatering time. The dewatering time is more of a volume-based empirical formula to assure they get the 80% trapping. One thing to note here, we're looking at the sediment graphs. You can see the sediment going in and sediment going out. Again, we're trying to hit that 80% as our magic number. One thing to really point here is SedCAD does not take into account the surface withdrawal effect of having the skimmer in the basin. SedCAD assumes that all the water is coming through the entire water column from top to bottom. And if that were the case, you would be letting out more sediment than you would letting when you're taking water just off the surface using your skimmer. So what we have found that in some cases, the review authorities, regulatory authorities, if you can explain this in your narrative, and let's say you've got 78% trapping or 79% trapping, and you're having trouble getting your basin to hit that magic number of 80%, in some cases, some reviewers will accept that narrative, and it's reasonable, call it engineering judgment, to assume you could get another, 1, 2, maybe 3%. Maybe more than that, but typically we don't shoot for pushing more than about 2 or 3% through that surface withdrawal effect. Again, if your 80% is not met, you can modify the pond. You can try another skimmer size. You may need to add a check dam or forebay or other measure in the pond, in series in order to hit it. As I said, some review agencies may accept slightly less than 80%. If you can explain SedCAD does not factor in the surface withdrawal, again, but what we're looking here is magical 80+% trapping efficiency. Usually that checks the box for your permit requirements and your sediment basin is good then. So that's been our advanced skimmer sediment basin design using SedCAD. If that was not enough information and you have other questions, please feel free to reach out to us. If you're doing this entire series and you'd like to get continuation credit for the whole series, please email us at info@rymarwaterworks.com. We will be glad to get that to you. Thank you so much for watching. Please keep an eye out for the other series videos that will be coming soon. Thanks.